Thank you very much for having the opportunity to speak. 1 second. Can you see my screen? All right.
Yeah, it's
okay. So yeah, moving from this island of Haiti now to the ocean. Yeah, thanks for the great talks before. It was very interesting. I want to present a new technique that developed, and we are using satellite imagery to survey whales in remote areas and thus enhance conservation efforts. And we have been starting this since 5 years to do this. And I just wanted to introduce you into this. And we had together with our sister company, HiDef, who does aerial surveying on animals overseas, and ourselves, we have been implementing our service SPACEWHALE. So yeah, the Earth's surface, as you know, is more than 75% of water, and especially high water, high offshore water, where we don't know anything of what's happening. We use it rather for industrial purposes and like as a traffic lane and so on. But there are whales outside, and we have just here on the right-hand side, just to see how the world ocean is actually surveyed for whales. You can see there are a lot of white spots off the continents to actually see whales. And before or up to now, we are using traditional survey methods, and that's when people are on the ship following transect lines, either like the Polarstern going down to the Antarctica and everything. What is seen from there along the transect line is recorded, what kind of whales and how many whales there are. But we have also this digital aerial surveys, as we do with our HiDef method and passive acoustic monitoring, to really see where animals are and are vocalizing and so on. But outside, there is still missing a lot in these high seas. And when we have a look at the Earth, we can now access a satellite, very high resolution, and now we can zoom into the high seas. The satellites we have been using so far was mostly from the company Maxar, that has the Worldview 2 with 46 centimeter resolution, so half a meter resolution per pixel. And we have been using, that's our favorite one, the Worldview 3, which has 31 centimeter resolution. And also Airbus has been bringing up another satellite that is called Pleiades Neo, also with 30 centimeter resolution. And yeah, what can we do about SPACEWHALE? We detect whales from space using these satellites, and we offer it as a service. So people who want to know where whales are, NGO, governments, and so on, can ask us to do so. And we determine the number and distribution in large areas where it's too challenging for traditional surveys. Because we can have a snapshot of this area, and then we can count any whale that is in there. And this is quite important information for baseline studies, population assessment, and conservation efforts to help evidence-based decision making. How does it work? Because how do whales look like from a satellite image? If you imagine that 31 centimeter per pixel, we have a blue whale, like here on a left-hand side, it is now recorded with a drone. So to see the details and so on, it's 30 meters long. If you divide it following the length in 30 centimeters, you can for sure see it in a satellite image. And that's what you see on the right-hand side. That is a snapshot. Also here is another blue whale, the largest animal on Earth, that is momentarily descending into the water. Just part of it is on the surface, but we still can recognize it on a satellite image. And that's also what you see again on the right-hand side. And here is another species that is called humpback whale. At the moment in the drone footage on the left-hand side, it's laying on its back with its flipper up. And it's a very playful animal that always creates a lot of waves. So it makes it sometimes a bit difficult to realize it in the satellite image. But here, this animal is lying on its side and has one of its flipper, so 4 flippers up in the air, and it's a humpback whale. So because of the satellite image, very high resolution satellite image, there is no archival data over water. Archival data are kept for terrestrial areas, but yeah, there is too much to process over water, and there's not really has been not really clients for this for the satellite image providers. So we had to train our algorithm, because you have to imagine like just 500 square kilometers or 4,000 square kilometers of high water, searching for a whale by just a naked eye. It tires people will overlook. So we decided to train an algorithm. And therefore, we took all the images we had before on aerial images from these digital aerial surveys, where the resolution or the ground sample distance is like 2 centimeters per pixel. And then we downsampled it to 31 centimeter resolution, which is the resolution that the satellite provides. So on the right-hand side, you see the minke whale that has been downsampled in the resolution. So how did we do this? We took the aerial images and downsampled it, and did tiling and tried to detect with an algorithm. We took the satellite imagery, and here we did something like pan sharpening, where low resolution multispectral image is merged with a panchromatic that is very high resolution, and then you get a colored high resolution, very high resolution image. And we have been training this with downsampled image, either from the digital aerial surveys, either from drone footage, but also from studies we have now undertaken already with satellite images, where you can see in the very low part, it's a southern right whale on the left-hand side and the blue whale on the right-hand side. And because the algorithm can't define the diverse species, whale species that are existing on Earth with their different behaviors in all the different locations, we have been training a very sensitive algorithm to detect anything that looks like a whale, like rather cigar shaped and so on. And then we go through these images that have been selected by the algorithm with our expert review team for a QA, and then they determine it to a species level. So I want to give you a little example. Here you see the southern right whales, where we have been taking a study from a satellite, and that has been off New Zealand in the Auckland Islands. And here you see in the upper part where the frame is, it's Podros, and that is a very known whaling area until the 80s. So whalers have been going there to do whaling on this species, on the southern right whales. And because this area has been so sheltered, it was so easy for them to unfortunately kill all the whales. And this is the area, a photo of it on the right-hand side. You can see that already since 1800, whales have been killed by whalers, and really pushing down the numbers until the 1950s, almost to zero. And now they are slightly recovering in this area, and coming back and reuse this area that has been used from them already 200 years ago and before. And we thought to do a satellite study there and to see if we can count the whales. So this is how it looks above. There is in the middle, there is a whale with a juvenile even, and then on the left-hand side, this is also a whale occurring. And also you have to believe us, we are experienced biologists, having been out on sea a lot and knowing how these whales look like. And this picture may be a little bit overwhelming, but just have a look on this map here. This is this Port Ross harbour, and then you can just look at the hollow circles. These are definite adult southern right whales, and when there is a black circle next to it, that's the juvenile. And we just have some probability categories here to see if it's really a southern right whale from the satellite imagery. But all the circles and squares are definite and likely whales, so there is quite a number of whales. And we had been looking at this square again because we realized that there has been a boat-based survey a day before, and we have been looking into this area and saw that the boat-based survey counted 25 adult whales and 16 calves, totaling to 41 whales. And from the satellite survey, we found 23 adult whales and 18 calves, also totaling to 41. So that was really nice to ground truth ourselves, and data were comparable to results of traditional survey methods. So that's an important step to realize that, and SPACEWHALE can complement data in explored regions and provide baseline data in unexplored regions. And where we have been doing some successful surveys is off Hawaii, down down here in Mexico, in the Mediterranean, in the Bay of Biscay, of Madagascar, and here down in Auckland Islands. So it has been already quite successful, and with SPACEWHALE we are providing data to find solutions for combining species conservation and the human use of the sea. So also by industry, such as offshore wind farm operators. But also what is very important to us is to provide a tool for mandatory baseline monitoring of whale populations, such as, for example, now the SDG goal 14, life below water. We want to have a healthy ocean and know how the health of the ocean is changing. So we think SPACEWHALE is a very good methodology to actually see how the population of whales is changing until 2030, and whales are quite good sentinels for the health of the ocean. And of course, we can fill knowledge gaps and thus enhancing conservation, for example, the 30 by 30 target also. We are also always on the lookout for drone footage from whales and dolphins to further enhance our algorithm. And if there are here in this Earth Science Conference people who are interested in doing a collaboration where we can contribute to MPA, Marine Protected Area designation or management, whatever is needed locally there, we are happy to collaborate. And sure, we're looking also for financial sector partners or philanthropic organizations and so on. And for that, I want to thank you, and I am open for questions. If there are any.
Thank you, Caroline, for your speech. The presentation was very well done. It was a very new topic. If anyone have any questions, you can ask. If no one has any questions, we can take a refresh.
Here's a quick question. So, hi, Kevin Adair from Chicago with Fuego del Sol, Haiti. How extensive do you think your process can grow to? What's the scalability? Where do you see your process, say, 10 years from now? Will we be able to potentially locate all the whales in the world? What's the long-term potential?
I think the long-term potential is really, really good. It's just hard to predict at the moment. So we have 2 satellites in this resolution orbiting the Earth at the moment. So I say we, but it's the satellite image provider, and we need to buy the images. But there are more to come. There are even some announced that are in a resolution of 10 centimeter, and like the one company is starting to launch another 6, probably by the end of the year. So they have other routes orbiting the Earth. So there are other times and possibilities when one satellite could fly over a certain area of interest. So I think there is this path in the future to have the possibility to survey and scale it over different oceans to certain times, only then being limited by clouds and maybe light, daylight. But the rest should be actually all right, but I can't tell you. It's highly depending when these satellites are launched and how we do have access, and also how they are willing to cooperate and so on. There, we still need to pay for these images. It's not like in the EU where Copernicus is for free, because it's also coarser scale, but this may also change into the future.
And I imagine currently there's more satellite coverage of land and populated areas, right? So
Yeah.
that's a challenge, because the areas that you're looking at have less population, and therefore it's less financially viable for the satellites to gather data in the regions where you need your data most.
Yeah, exactly. That is true. That's why we had also to take, we didn't have any archival footage. We needed to circumnavigate it with other images that we downsampled, but that worked out fine. And I think there's probably also more need in the future, but or maybe all the people are getting louder to know, who want to know about the health of the ocean. So yeah, I think there is a way to go, and they are all aware of it, and people are researching on this and so on. So yeah, I think there's a way.
Thank you. I'm optimistic too. I think you have a lot of potential, and it would be great to know where all the animals are that we especially need to save.
Yeah, thank you very much for your feedback. Yeah, we think so too. And also, I mean, I hope you or everyone has heard that really whales are also quite influential for like carbon reducing and so on. And there it's so much evidence that whales are what they do, and how they do algae blooms and so on, or like feed primary production, and all the cycle is working like this. So it is really a sentinel for the health of the ocean.
Excellent, great. Well,